Okay, so here's an example of a case where you would have a double bond. So let's start with, let me go to the periodic table. All right, so I will create a molecule. We'll do carbon dioxide, so carbon and oxygen. So it's going to be the molecule. Carbon dioxide, so the formula is CO2, right? So we're going to have 2 oxygen atoms and 1 carbon atom. Carbon is going to go in the middle, and that's because carbon can form more bonds because it has fewer valence electrons. So if we look back at the periodic table, let's start by identifying it's a covalent bond because it's between 2 nonmetals, and now how many valence electrons? Fourth column, carbon has 4, oxygen has 6. So I'm just going to fill in the number of valence electrons for each of these atoms. So if I want to form bonds, every bond that I form is going to be an electron between each atom. So for example, there are 2 here, so they can share these 2 electrons. Same here. Let me just erase this so it's a little straighter. It's kind of ugly. It'd be crazy. All right, let me grab my pen. Let me just redraw that real quick. So that's better. Okay. Right, so I have 6 valence electrons. Draw my line over here. So now they're sharing these 2, right? So I haven't created or destroyed electrons, right? So now if I count each of these up, carbon has 1, 2. Each bond counts as 2, right? Because they're sharing them. So it's 1, 2, 3, 4, 5, 6. Octet rule says that I want 8 electrons around each atom, okay? Unless it's hydrogen, because then it's going to be 2. Because hydrogen is stable when it has helium's configuration. So hydrogen is the exception. Okay, so how many valence electrons do I have in oxygen? 1, 2, 3, 4, 5, 6, 7. So I'm 1 off on oxygen, and I'm 2 off on carbon. So what I'm going to do is I'm going to take this electron and this electron to create a double bond. Okay, 1 from each atom, right? And then I'm going to do the same over here. Okay, so I've taken that valence electron from here and here. And so I have 2 double bonds. Now let's count them up. Remember, each bond counts as 2. 1, 2, 3, 4, 5, 6, 7, 8. So carbon's happy because it now has 8 valence electrons. Okay. What about oxygen? 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Think of the octet rule the same way you think of ions, right? An ionic molecule balances out the charges, so they have this like net zero charge. This sharing of 8 is that same concept of stability. All right, so that's carbon dioxide. Okay, so here's do another one. This is carbon monoxide, CO, right? 1, 2, 4, 2. So let's do the same process, right? Form a bond here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, right? So now I'm going to get rid of okay. So now I've got this. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? Still not stable. So this guy could actually form a triple bond. Sorry, I got a little interrupted. So, okay, So now what we're going to do is, and this is carbon monoxide, right? So what I'm going to do is I'm going to form a triple bond. So if I form a triple bond here, I'm going to move, I had 2 lone pairs. So I'm just moving one of the lone pairs here, and I'm moving these 2 over here, right? I'm just moving them around. So carbon monoxide is an example of where you would have a triple bond, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So those are 2 examples of where you have it. And it's just about figuring out how to satisfy the octet rule. It's a little bit of trial and error, but those would be 2 examples of that.